So hello everyone. So from this session onwards, we are going to provide you all the most important subject of this SEM for ECE, that is control systems. Okay, the subject code is BEC 403. We are providing you all the model question paper solutions for this subject control system of all the modules. Okay, so from this with this video we are going to start with the model question paper 1 solutions from module 1. Okay, we have discussed all of them. We have tried to solve all of the questions for you all, okay, in a short amount of time. So please, I request you all to don't skip any part of the video, and please refer this video. The PDF would not be available. Okay, so whatever I tell you in the video, you can make a hand note of it and you can note it down, because it would be beneficial for you only. So now let's start with the first question, that is 1A. Okay, 1A of model question paper 1. Okay, so the question is, draw the equivalent mechanical system and develop the force voltage and force current analogous circuit with the relevant equations. Okay, so this is for 10 marks. So here is the translation mechanical system. They have given it here. Okay, for this, the equivalent mechanical network you should be drawing. I told you that the first step for this is we need to be identifying the displacements. In this case we have two displacements. How many displacements, that many nodes you should be drawing for x1 of t and x2 of t, and we need to be checking the force is in which direction. The force here is in this direction of f of t. It is to the opposite to the displacement of x1 of t. So that's why from this node x1 of t we should be drawing one force here. After that, we can see that the spring K1 is happening due to this displacement x1 of t. So that's why from this node draw this K1. Similarly M1 and B1. Okay, then we can see that K3 and B3 are between the two displacements x1 and x2. So that's why I am drawn the K3 and B3 between these two displacements x1 and x2. And for x2 of t, the sum of the quantities are M2 and B2, as well as M2, B2 and K2. These are all happening due to the displacement taken of x2 of t. So like this I have drawn the equivalent mechanical network. Okay, then the equilibrium equations at node 1, also at node 2, that is f of t is equal to m1 d square x1 of t by dt square plus b1 dx1 by x1 of t by dt plus b3 dx1 of t divided by dt minus dx2 of t by dt. Okay, since this b3 is between these two displacements, so that we should be considering both the displacements. Also k1 into x1 of t plus k3 into x1 of t minus x2 of t. So at node 2, this is the equation at node 2. Okay, 0 equal to m2 into d square x2 of t by dt square, and this is the whole equation for b2, b3, k2, k3. So please note it down and note it as equation 2. Okay, so now after writing the equilibrium equations, apply FV analogy for equation 1, whatever is there. That is FV analogy states that force is replaced by voltage. Okay, M is replaced by L, B is replaced by R, and K is replaced by 1 by C. Okay, and also X is replaced by Q in place of force voltage analogy. Okay, so that's why I have replaced all the terms. That is L1 d square q1 by dt square, R1 dq1 by dt plus R3 dq1 by dt minus dq2 by d3 plus 1 by c1 into q1 plus 1 by c3 into q1 minus q2. And here I have to see that here d square by dt square I have taken it common and wrote it as d by dt of dq1 by dt. Then we know that dq by dt, if we I is equal to dq by dt, right? So dq by dt would be replaced by the current I. So since it is the charge q1, so the current would be I1. Similarly R3 into I1 minus I2, 1 by c1 into integration of I1, because we know that since I is equal to dq by dt. Okay, so what this q would be, if we take this d by dt to the other side, it would be integration of I, right? Yeah, so that's why this would be integration of I1. Similarly 1 by c3 into integration of I1 minus I2. Then I have solved it. So this is again I1 di1 by dt. After this we should be taking the Laplace transform in order to convert it into the S domain. Okay, that is L1s into I1 of s. We know that d by dt is replaced by s and integration sign is replaced by 1 by s. Okay, so this detailed explanation is available in our channel. In the concept video you can refer it. A detailed explanation related to the mechanical systems, we have done it to you all. Okay, so I'm just going to go on showing the problems. Okay, similarly for equation 2 also I have written it the same thing, and I've taken the Laplace transform and written the equation okay. And from equation 3 and 4 we would be getting this equivalent electric network, okay. First thing, for electric network, for FE analogy, we know that we should be representing in terms of mesh analysis, okay. So that's why I've drawn these two loops here, and along with that, in this loop we are having the components L1, C1, R1. So if we look at this equation, which and all are the components present in I1 loop, that is L1, R1 as well as 1 by C1 or C1. Since it is in S domain, if you want to represent in the time domain, it is 1 by C1 is equal to C1, right? 1 by C1s, okay. And R3 and 1 by C3 are between the two loops, since it is I1 minus I2. So R3 and C3 are between the two loops of I1 and I2. It's represented like this. Similarly, in this equation also we can see R3 as well as C3 are between these two loops, okay. So like this we are getting the equivalent electric network. Similarly, for FI analogy, force is replaced by current, and displacement x is replaced by phi, okay, and m is replaced by c, b is replaced by 1 by r, and k is replaced by 1 by l, and all the necessary substitution I've done it, so you can pause the video and refer it, okay. So this is the value of I of s for equation 1. Similarly, for equation 2, I have again substituted the terms and solved it separately, and by taking the Laplace transform I have converted from time domain to S domain. And here in this case, the equivalent electric network we should be representing in terms of node analysis, right? For FI analogy, I have told you, that is what and all the voltage are there, it's present, that is in T domain represented, that is V1 of T and V2 of T, two voltages, so two nodes. So between V1 of T and V2 of 3 we have R3 and L3. If we compare these two equations here, okay, if we compare these two equations, we can see that R3, 1 by R3 and 1 by L3, these two are having the two voltage sources V1 and V1 of S minus V2 of S in both the equations, 1 by R3 and 1 by L3, so that we can say that these two components are between the nodes V1 and V2, and rest all the components are, we should be representing them in parallel, okay. Whenever we want to represent the equivalent electric network for FI analogy, we should be representing it in parallel, and in FV analogy, it should be representing it in series, okay. That hope you might be knowing it, okay. Yeah, so now let's get to the next question, that is 1b, okay. So the question is, develop a translational mechanical system for the given FV analogous circuit shown along with the differential equations, okay. So this is the given circuit here. They have given this circuit, the FV analogous circuit they have given. So in this problem, what we should be doing is, they have given the FV analogous circuit. Our goal is to find the translational mechanical system. For that, what we should be doing is, consider that this is the final circuit which we have got, okay. We should be going in a reverse order here. In the reverse order, the same problems for mechanical system, what we are doing, we should be going in a reverse order. First thing we should be knowing is, whenever we have an FV analogous circuit, how many loop currents are there? Number of loop currents is equal to number of displacements, okay. So in this case we have 5 loop currents, so that's why we can say that there are total 5 displacements, okay. So now from loop I1, that is from first loop, write the equation by taking the KVL in S domain, okay. That is L1S into I1 of S, okay. L1 into S, because we know that whenever we take the differentiation, d by dt is replaced by s here, okay. So that's why we need this when we are taking the inverse Laplace transform. So L1s into I1 of s, and 1 by C1s into I1 of s, R1 into I1 of s minus I2 of s, since R1 is between these two loops I1 and I2, that's why, and this C2 is between these two loops I1 and I3, so that's why I've written 1 by C2s into I1 of s minus I3 of s. Then again, after taking the inverse Laplace transform, what would be happening is L1 and s is replaced as when we take Laplace transform, d by dt is replaced by s. So when we take inverse Laplace transform, s is replaced by d by dt, okay. Similarly, same goes with here, 1 by c1s. So 1 by s is replaced by the integration sign here, so that's why I1s is replaced by I1, okay. Same goes with here, R1 and I1 of s and I2 of s is replaced by I1 minus I2, and 1 by C2s. So here 1 by s we have, so 1 by s is replaced by the integration sign here when we take the inverse Laplace transform. Also, now what we should do is L1 into d by dt of I1. See, we know that I is equal to dq by dt in place of FV analogy, so that's why I1 we should be replacing it by dq1 by dt, and integration of I1 should be replaced by q1, okay, and I1 minus I2. So again I1 is dq1 by dt and I2 is dq2 by dt. So 1 by C2 into integration of I1 is q1, integration of I3 is q3. Then again simplify the equation and write it, that is v of t is equal to L1 d square q1 by dt square plus 1 by C1 into q1 plus R1 into dq1 by dt minus dq2 by dt plus 1 by C2 into q1 minus q3. So now from this equation what we should be getting is FE analogy. For FE analogy we should be replacing some of the terms, that is L1 should be replaced by M1, R1 should be replaced by B1, F should be replaced by V, 1 by C1 should be replaced by K1, 1 by C2 should be replaced by K2 and Q should be replaced by X. Okay, yeah. So now what should we be doing? L1 in place of L1 substitute the M1, in place of B1 substitute R1 substitute as B1, in place of K1 in place of 1 by C1 substitute as K1, in place of 1 by C2 substitute it as K2, and in place of Q substitute it as X, okay, the displacements, okay, and rewrite the equation. Okay, so then whatever equation we got, name it as equation 1. Similarly for all the loops we should be doing it as it is, all the 5 loops here, same way, same procedure. Similarly from loop I2 try to write the equation. Okay, for loop I2, since we have only 2 components R1 and C3 in I2, both of them are between, R1 is between I1 and I2, so that's why I2 of S minus I1 of S, since we are taking from loop I2, so that's why I2 should be coming first, and 1 by C3S is between I2 and I4, so that's why I2 of S minus I4 of S. Again take inverse Laplace transform, okay, and substitute the following terms and get the equation and name it as equation 2. Similarly for loop 3, again C2 and R2. For loop 3 we have C2 and R2, okay, then C2 is between I3 and I1 and R2 is between I3 and I4. So similarly I have substituted it, okay, and take the inverse Laplace transform and solve it, okay, and this is the equation we get, equation number 3. Note it down. Similarly for loop I4 I have taken it, what and all are the components are present, take that and write it in form of this equation, take the inverse Laplace transform, do the necessary substitutions, and this is the equation we get for equation 4 from loop I4. Similarly from loop I5 also same thing, write the equation taking inverse Laplace transform, solve it, and this is the equation we get. Okay, so now whatever are the five equations which you have got, those all equations are called as equilibrium equations. Okay, so now from the equilibrium equation 1, 2, 3 and 4 and 5 we get the equivalent mechanical system that we should be writing. Okay, that is equivalent mechanical system. We have 5 mesh loops, right, 5 loop currents, so that's why we should be representing 5 displacements, okay, x1 of t, x2 of t, x3 of t, x4 of t and x5 of t, and do the necessary. And in place of x1 of t in the first equation we have the force f of t, right, okay, then in place of x1 of t, m1 and k1, and we know that between x1 of t and x2 of t we have this b1 if we look at all the equations, and also between x1 of t and x3 of t we have k2. Okay, between x2 of t and x4 of 3 we have x4 of t we have k3. Between x3 of t and x4 of t we have b2. Okay, then from x4 of t draw one mass here m2. Then between x4 of t and x5 of t we have b3, and here this is k4 in place of x5 of t. Okay, compare all the 5 equilibrium equations which you have got. Okay, then try to write the necessary components between the nodes here. Okay, this is similar to FI analogy only. What and all are the 5 equations which you have got, just compare it and see that which component comes between the nodes and which components comes under the nodes. Okay, so now using this mechanical system, and like this we should be building the translational system. Okay, so if we compare it carefully, start from the utmost right hand side. Okay, first mark the mass m1, along with that from that mass draw one spring k1, and from mass m1 mark the displacement x1 of t, and since force f of t is due to this displacement only, so that's why here only the force would be taking place f of t. Okay, and also we have k1 here, and also x1 of between x1 of t and x2 of t we have b1, so that's why what we can do is just behind this mass apply one friction b1, and from one point b1 here mark one displacement x2 of t, so that b1 comes between these two displacements. Also k2 is between x1 of t and x3 of t, so that's why from m1 mark one spring k2, and from this point draw one more displacement downwards, that is x3 of t, so that's why this spring would be coming between x3 of t as well as x1 of t. Okay, so similarly what is between x3 of t and x4 of t, between it is b2. So that's why what we can do is from this x3 of t draw one friction b2 and mark it to the mass m2. Okay, the m2, draw it m2, and from n2 draw one more displacement x4 of t. Okay, so that we can see that from x4 of t and x2 of t we have this spring k3, right? So that's why mark this spring here and join it with this friction x2 of t. So this k3 would be coming here. Okay, similarly b2 would be coming in between x4 of t and x3 of t. So also this b3 here would be coming between x4 of t and x5 of t. So that's why from this point draw one more displacement x5 of t. Okay, then after that finally one spring for x5 of t, that is k4. So hope you understood this translation mechanical system. So all this this problem is very important, so note it down. Okay, so the next question is comparison between open loop and closed loop control system. So here I have made some of the points for open loop and closed loop control system. This is the difference between them. That is, open loop control system has less accuracy. Okay, closed loop control system has more accuracy. Open loop control system is sensitive to noise, disturbances and external changes in environment. Closed loop control system is less sensitive to noise, disturbances and external changes in environment. Open loop control system, from the point of view of stability, it is easier to build, and closed loop it is more complex and expensive. Open loop it is less in power and cost. Closed loop it is higher in cost. Open loop it is convenient when output is hard to measure or not. Then robust sensors are used in case of closed loop control system. Output quality is not guaranteed in place of open loop control system. Output quality is maintained and it is guaranteed in place of closed loop. Recalibration of device from time to time is necessary. Recalibration is not necessary. Feedback element is absent in case of open loop, and feedback element is present in case of closed loop control system. The error detection is absent in case of open loop, and error detection is present in case of closed loop control system. And transient and steady state error cannot be controlled conveniently in place of closed loop control open loop control system, and transient and steady state error can be controlled conveniently in place of closed loop control system. Okay, so these are the few of the main differences here between open loop and closed loop control system, so you can note it down. Okay, this is very important. Also, I have provided you some of the advantages of closed loop control system over the open loop control system. If you want, these are the 4 important points here. You can pause the video and you can note it down as well. Okay, so this is the next question, 2b. For the buffer amplifier shown in the figure, obtain the transfer function E naught of S divided by EI of S. Okay, so this question is very important, but yet it is very easy, you can solve it. So this is the buffer amplifier shown here. Okay, they have given the connections R1, C1 for a buffer amplifier, and R2, C2, and these are the two EI of T and E out of T are the input and output sources. Okay, so here first what we should be doing is assume the gain of the buffer amplifier to be equal to 1. Okay, this assumption is very important. To the buffer amplifier gain, you should be assuming it as 1. Now what we should be doing is we should divide the network into 2 parts. Okay, that is part 1, that is this input side part. Okay, whatever this input part is there, this is one part, and whatever this output side part is there, divided into 2 parts like this. Okay, so part 1 I have written it rewritten the circuit in and replaced by time domain in S domain. So let's say what are the necessary changes to be done is R1 should be remaining as it is. In place of capacitor, we should be replacing it by 1 by C1 of S. Okay, and EI of T is replaced by EI of S. So here what I have done is this buffer amplifier I have removed it, and in place of this output side whatever is there right here, I have replaced that by V1 of S. Okay, so the what this V1 of S we should be assuming it as the output voltage across the capacitor C1. Okay, so I'll tell you why. Okay, in part 1 circuit, this is the simple circuit and this is the output voltage which I've assumed, that is V1 of S. Okay, so now apply KVL separately for these 2 loops here. KVL on this loop, okay, that is EI of S minus R1 into I of S, since the loop current is I, minus 1 by C1S into I of S. So therefore EI of S, if we take these 2 terms to the left hand side equal to 0, then it would be EI of S is equal to R1 plus 1 by C1S into I of S. Since I of S is common, then name this as equation 1. Similarly for this loop here, apply the KVL, then we would be getting V1 of S minus 1 by C1S into I of S equal to 0. So therefore V1 of S is equal to 1 by C1S into I of S. So name this as equation 2. So now from equation 2 we get I of s is equal to v1 of s into c1s, right? So that make that necessary change here and name it as equation 3. So now what we should be doing is substitute this value of I of s in equation 1 whatever we have got, that is ei of s is equal to r1 plus 1 by c1s into, in place of I of s replace it by v1 of s into c1s. Okay, take the LCM so that we can cancel the c1 of s. Okay, so therefore the remaining term of ei of s is equal to r1 c1s plus 1 into v1 of s. Okay, so name this equation as equation 4. Okay, after this go to the second part of the circuit, that is this output part here. So here what we should be doing is, this input side is there, right? Okay, this input here mention this as input voltage v2 of s, and assume this v2 of s as the input voltage for this part 2 circuit here, and again redraw the circuit here, and with this output voltage as e naught of s. Okay, in S domain, where this is the loop current I of s, which is common for these two loops. Then again apply KVL for this loop, that is v2 of s minus r2 into I of s minus 1 by c2s into I of s is equal to 0. So therefore solve for v2s, so that's why we are getting r2 plus 1 by c2s into I of s. Okay, so this equation, mark it as equation 5. Then after that, similarly for this loop here, this loop what we are getting, e naught of s minus 1 by c2s into I of s equal to 0. So therefore e naught of s is equal to 1 by c2s into I of s. Okay, so name this as equation 6. Okay, so now from this equation we can get the value of I of s now, that is e naught of s into c2s. Okay, from equation 6. So now what this value of I of s we should be substituting back in this equation 5 here. Okay, that is v2 of s is equal to r2 plus 1 by c2s into whatever the value of I of s just now we have proved from equation 6, that is e naught of s into c2s. Okay, then after that what we should be doing is v2 of s, solve for again here, take the LCM so that we can cancel c2s. So therefore v2 of s we would be getting it as r2 c2s plus 1 into e naught of s. Okay, so now name this equation as equation 7. So now we have considered one condition, right, in the starting assumption, that is the gain of buffer amplifier should be equal to 1. Okay, so here in the buffer amplifier the gain is generally output voltage divided by input voltage. Okay, yeah, so here in this case, in case of buffer amplifier, this is the output voltage and this is the input voltage. Okay, but here in case of the input voltage of buffer amplifier is the output voltage for part 1 which you have taken, that is v1 of s. Okay, and also the output voltage of buffer amplifier here is the input voltage for part 2 which we have taken, that is v2 of s. So that's why we can say that v1 of s divided by v2 of s is equal to 1, so that we can take this v2 of s to other side, so that we would be getting v1 of s is equal to v2 of s. Okay, so now consider equation 4 which you have written, rewrite it again, that is ei of s is equal to r1 c1s plus 1 into v1 of s. Okay, so therefore solve for v1 of s. Okay, bring v1 of s together to one side, then ei of s is equal to r1 c1s plus 1. Okay, so here we have got the two equations for v2 of s as well as v1 of s, but just now we have proved from the gain that v1 of s equal to v2 of s, so that we can equate these two terms. Okay, so these two terms, so whichever we have got from v1 and v2, so we can equate that, that is equation 7 equals to equation 8. Then we would be getting r2 c2s plus 1 into e naught of s is equal to ei of s divided by r1 c1s plus 1. So therefore separately do it for e naught of s and bring this ei of s down here. So therefore, and bring this r2 c2s plus 1 to the other side. So therefore we would be getting our transfer function as 1 divided by r1 c1s plus 1 into r2 c2s plus 1. Okay, so in this way you should be solving this problem. Hope you understood this. Okay, this is very easy yet very tricky one, so hope you understood this problem.